Okay, I think I've got it set up here. Trying to get I'm using the iPhone this time to track what I'm writing, but it's trying to be smart about what's in the picture and what's not, so it's zooming in and out all the time. So this is a thing I've been trying to fix this morning before I started. I'll just move this down a little bit just to get it even closer. Okay, well, it's in the business shot now. So today, I'm going to do Math Academy streaming number 2. Still working things out, obviously. I'm planning to go for about a half an hour. Might go a little bit longer, depending on how things are going. And I really wish this weren't trying to be so smart and clever. But anyway, here we are. I am on Math Foundations 2. And I'm 98% of the way through it. So I've mostly covered all these things. And after this is going to be Foundations 3. According to its algorithm, it thinks I'm going to finish it this Saturday. So without much further ado, I'm going to do one last check to make sure that this is actually streaming. And I'll go from there. Okay, cool. Then let's kick it off again. Feel free to send me messages in the chat or something as well. Close this door. Okay, so up first, let's see, we got a multi-step, we got lessons and reviews. And I feel like I'll start with the multi-step. Okay, f of x equals x to the a plus b x. G of x equals ae to the x, and h of x equals cosine of x plus 3. A and b to be determined. All right. Following facts about the function y equals cos x. Assume that n is an integer. The domain of the function, actually, so I want to take a screenshot of this. I think there's a little bit of a rendering problem there between is and x. Okay, complete the facts about the function y equals cosine of x. The domain of the function is negative infinity to infinity. The range is, which is cosine x minus 1 to 1 inclusive. The period of the function is 2 times pi. Nailed it. Alrighty. A is the maximum value of h of x, cosine plus 3. Then a equals, max here is 1, and plus 3 is 4. Graph is generated by cosine of b of x. Then b equals, okay, so it goes from here to here, 1 period in less than pi, and it looks like it does 1.5 periods in pi. Does that look right? So if that's half, that's another half, gets me back up here. So yeah, 1.5 periods in this pi. So t equals 2 pi on b. 1 period is in, so 1.5 is in, so 3 halves. Come on, Jonathan, think through this. 1.5 times. So it's usually 2 pi to go all the way around, and now it's this is the stuff where it's like it needs some t to be smarter. Okay, let's try the other way around. Maybe let's try and just write it down and see if it's right. So usually it takes 2 pi to go the whole way. So b is 1, but in this case it goes of 1 period equals pi 2 pi over 3. So then b would be 2 pi over 2 pi times 3. So b would equal 3. Now, if b equals 3, then what happens here? When x is, so cosine here, so if I put in pi, 3 pi would put me at 1, 2, 3, negative 1. So if x equals 1, b is 3, this means 3. 3 times if x equals pi, and I say b equals 3, then it means that 3 pi is what is in his cosine of function, which means it should be equal to, question mark, minus 1, and it does in fact equal minus 1. My goodness. Okay, so b equals 3 is my answer. Good gracious, that took a long time. Yeah, it's 2/3 pi. Yeah, okay. I usually go really fast on these, but sometimes when you're streaming, you end up doing a little bit of a slower brain situation. Okay, integral of 3 over pi squared d is plus c. Okay, so this would be 3 times integral of let's say x to the minus 2 dx plus, so add 1 and then divide by that, so it's minus 1, so 1 over minus 1 x to the minus 1 plus c. So we get 3 times, so negative 3 over x plus c. Negative 3. Sure, let's do 1 over x and then do c. F of x, okay, we're doing f of x over integral of f of x over x cubed dx. So f of x is x to the a, so x to the a over x cubed plus b times x over x cubed Just double check I've written that down right. Okay, that looks right. A to the x, x to the a, b of x, b times x. Okay, so let's start with this one. This goes to 2, and so x over 2 is the same thing we just did here. So it's 1 on -1, x to the -1, plus c, which means, let's just make this look nice. Negative b over x plus c is this part, and then we've got to do this part. X to the a. So this is the same as integral of x to the a minus 3 dx. So add 1 and then 1 over that, so 1 over a to the minus 2 x to the a minus 2. Okay, so looking nice in the end, x to the a minus 2 over a minus 2 minus b on x plus c, and they've already added the plus c, so I just need to fill in the blank for this part. Let's do it. I feel like, well, we'll see how it goes. X to the a minus 2 over a minus 2. Wait, have I solved for a yet? Have we actually figured out what a is? Oh, then a equals 4. If a is this, then a is that. So I'm going to assume that if a is the maximum value, then a equals 4 is actually the case, in which case we know what a is. So a is 4. So instead of a minus 2, we just say 2 and 2. Double check here. No, let's redo that. The right hand side's still okay. We actually probably also know b, don't we? Alright, Jonathan, this is multi-step. You used the information from before. Okay, so let's think about this. If a is 4, I'm going to assume a equals 4, and b equals 3. Let's redo this. The integral of x to the 4th over x cubed plus 3x over x cubed dx for everything. F of x over x cubed. Let's do this. So this is integral of x. X to the 4th plus, so this goes down to 2, 3 times x to the minus 2. So we get this, x squared on 2 plus, so it'll be minus 3 on x plus c. X to the 4th, x over 3. X to the 4th, x to the 3rd is x straight up. This actually is correct, x squared over 2. Okay, good. I got it both ways. We're not writing things in terms of a anymore. Let's just redo this. X squared on 2 plus -3 on x plus c. It turned out to be a lot easier than I was trying to make it at the beginning. Let's keep going. If k equals, then g of x minus f of x we're looking for dk dx. Okay, so a equals 4, b equals 3, g of x is 4e to the x, f of x equals x to the 4th plus 3x. So let's see here, g of x minus f of x. Is k of x, and we're looking for dk dx. To the x to the 4th minus this thing, d dx. Okay, so this is all separable in a nice way, so this is just 4e to the x minus 4x cubed minus 3. E to the x minus 4x to the 3 minus 3. Double check. 4e to the x minus 4e cubed minus 3. Okay. Correct. Okay. Find the slope of the tangent to the curve y equals k of x, where x equals 0. So the slope is just the ddx on that thing, so just plug in 0 for this one. So 4e to the 0 minus 4 times 0 minus 3. 4e to the 0 is, this is 1, so it's 4 minus 3 equals 1. Slope of 1. Tangent to the curve, x equals the y-axis, x-axis. Find the value of c. Okay, so we've got ourselves the tangent. The slope is 1. So y equals mx plus b. In this case, where x equals 0, the y equals k. Find the value of c. So tangent to the curve at y equals x, when x equals okay, so there's some curve here. This is the curve. It goes around somewhere. It's somewhere here. When x equals 0, there's a tangent to the curve at the point where x equals 0. So there's along this line, there's some tangent here, and then there's the intersection of that thing with the x-axis is at point c, comma 0. So we need to find the equation of this line. We know the slope, which is already 1. So this is the equation for the line. We need to know where b is, and we do that by plugging in x equals 0 here. So 4e to the 0 minus 0 minus 0, 3 times 0. Gone. So this is 4. So y equals 4 is equal to 1 times x, which is 0, plus b. So b equals 4. And plug that back in. We're looking now for when y equals 0 is equal to c times 1 plus 4. So c equals negative 4. little bit of a roundabout way of doing that, but got there in the end. Okay, so I nailed all the questions, 11 points plus 2. So my daily goal is 15. I got 13 right now. Then go through some lessons here. Currently at about 20 minutes here. I'll keep going here, and one thing I like about this especially is that it is it's basically you have a sense of how much effort it takes to get to the next, like how much to learn. So if you want to know like how long will it take me to learn all of Foundations 2, it'll take me another 5 days or something, and it's just a matter of turning the crank. Basically, you turn the effort crank, and then the knowledge just sort of comes as a, well, there's effort on your part, but you kind of have a sense of how much effort it takes to encode in your brain either the things or to relearn the things that you've learned previously. All right, so let's keep going for just a little bit. I'm feeling pretty strong still, and yeah, let's see here. Thanks for. Okay, rational equations with 3 terms. How hard could this be? To solve an equation that contains multiple rational terms, multiply both sides by the least common denominator. X cannot be 0. Multiply both sides by the least common denominator. The equation has that. So least common multiple is that. So least common multiple of X. I don't remember ever writing it down like this, but it's kind of fun. I mean, I get it, what's happening here, but it's just like the least common multiple function of these 3 terms is that whole thing. So multiply both sides of the equation by the least common multiple, and we get everything's still here, and we have to remember to not get the x equals 0 piece. Let's keep going. Oh, it's an example again. Solve a rational equation. One distinct linear denominator. Okay, so you throw an x across everybody, and yes, and we also make sure that we can't allow the solution to be there. Okay, this all makes sense to me. Solve for y, where y equals, and everyone has the same one, so you multiply everything by 3y. And I'll just do that in the first step. So y plus 1 equals y minus 2, plus 2y minus 2. And we have to remember that y cannot equal 0. Okay. So what does y equal here? So let's start throwing y's over to, let's go y to the right here. This y goes over here and cancels this y. So we have 2y on the right. That's taken care of. Minus 2 is minus 4. So add 4 over here. So 1 plus 4 is 5. So we have y equals 5 halves. B. Alrighty. Solve for m. Again, we have a thing where we have to make sure that we know that m does not equal 0. 3m minus 1 plus m plus 2 equals 2m plus 3. I've already just multiplied through by m cubed. Let's see, where does m want to be? M wants to be on the left. So let's throw m to the left and throw the rest of it to the right. So 2 minus 1 just goes to 1. That's taken care of. So minus 1 on this side, so it's plus 2. That's taken care of. We'll just leave an m on this side, cancel the m on this side, 2m on this side. So we have m plus m, so 2m equals plus 2, so m equals 1. Let's just double check real quick. If m equals 1, we have 3 minus 1 is 2, plus 3 is 5, and equals 5. Yep, okay, so m equals 1. Solving rational equations containing 2 distinct linear denominators. Okay, so this is where we have to do the least common multiple trick. So 8x is indeed the least common multiple. Multiply through by everything. Certain things cancel, other ones don't. And we have to make sure to remember x cannot be equal to 0. I feel like this is foreshadowing in like a fictional story or something. So if I have n satisfies the equation, n minus 2 on n equals 3 minus 2n on 5n plus n plus 1 on n. So multiply through by 5n, and we get ourselves 5n minus 2, 3 minus 2n plus 5n plus 1. Let's not get too fancy, let's just do it. So this is 5n minus 10. This is 5n plus 5, 5n plus 5. 5 plus 3 is 8, minus 2 plus this is plus 3n, is n plus n minus 10. Let's throw the n over here, and throw the 10 over here. So we have 18 equals 2n, it means n equals 9. Boom. Question number 4, maybe I can finish out in this little corner here. 4 minus w on 3w plus 2w minus 1 on 2w equals 2/3. So the least common multiple here would be 6w. So 6w here, the w's cancel, this becomes 2 times 4 minus w, plus this is 3 times 2w minus 1 equals, again, 6w is our term here, so it will be 12w over 3, which is 4w. Let's distribute the things on the left here. So we have 8 minus 2w plus 6w minus 3 equals 4w. This thing becomes 4w. Uh-oh. So 4w equals, well, this thing cancels on each side. So 5 equals 0. This means no solution. You're not going to fool me. Not today. All right. 3 distinct linear denominators. And it's the same trick as before. Least common multiple, multiply through by everything. Everything cancels. Remember below, x can equal 0. And x is this one. Okay. Okay. Y plus 2 on y minus 2 minus y on 3y equals negative 4 on 9y. So we need to multiply through by 9y would do it. We have 3 different ones. 9y just means that this is 9 times y plus 2 times 9 is, so divided by 3y, y's cancel, just multiply by 3 times 2 minus y is equal to, and this just goes away to 1, so minus 4. And we have another no solution possibility here in this in the answer, so let's give it a shot. 9y plus 18 minus 6 plus 3y equals negative 4. Negative 3 plus 3. so this thing goes to 12. That goes to 12y plus 12 equals negative 4. This is plus 12, so we can move it on this side, and it's minus 12. So it's minus 16 is 12y. Y equals negative 4/3. And that is indeed a solution, and I'm just feeling lucky, so I'm going to hit go. Which value of w satisfies this equation? 2w minus 3 on 3w equals 1 minus w on 2w minus 4w minus 1 on 9w. Alright, Jonathan, let's think about this. So the least common multiple would be not 9. Looks like it's 18. Okay, so we're going to multiply by 18w. So that means this is times 6. This is times 9. This is times 2. Okay, so let's do that. This is 12w minus 6 times 3 is 18 equals 9 minus 9w minus, let's just go ahead and distribute that. So it's 8w plus 2. And distribute the 1 to there, multiply by 2. And again, no solution is a possibility, so let's take a look at this. Let's throw the w's to the left and all the other numbers to the right. So this together, negative 9 plus this is negative 17w. And 2 plus this is 11 plus 18. And then we take negative 17 to the left. So that means it's plus 17, so 29w. 7 plus 2 is 9, 2, 2, 9. If I count everything right. Okay, so this is 29 equals 29w. Fair enough. And w can't equal 0, and it doesn't, so w equals 1. Rational equations containing quadratic denominators. Least common multiple has the square in there because you got to do that. Makes sense. Let's keep rolling. 3 on 2w. 1 on w. Minus 1 minus w on 3w squared. So least common multiple is 6w squared. Let's pull that through. So 6w squared ends up being, 1w cancels, that thing goes to 3w times 3, which is 9w equals 6w squared. One of the w's goes away, so 6w minus, and the squared goes away, and this is just multiplied by 2. Minus 2 minus, it's positive 2 times this thing, so it's plus 2w. And so let's combine these as 8. 2. So these two being 8 means, throw it over here, subtract 8, w equals minus 2. Final answer. Correctamundo. Last question. And I've got them all right so far. So if I get this, I get the bonus. If I miss it, then I have to do extras. Let's not mess this one up. Come on. We need a new piece of paper for this. Last one. Drum roll. Let's do it. 1 on m equals 2 on m minus m minus 8 on 3m squared. Remember, m can't equal 0. That's not one of the answers here. Okay. So the least common multiple here is 3m squared. So 3m squared, come on. So just 1 times this, take out one of the m's, is 3m equals, and we have 2 times 3m, so 6m minus, so 3m squared just goes here, so minus m plus 8. Okay, so this becomes 5m plus 8, and then there's 3 over here, so the 3 off to the right, and 8 over here. So minus 8 equals 2m, m equals minus 4. It's an answer. I'm feeling lucky. Let's do it. Boom. I've got 12 plus 3. Not bad. Okay, so I've got 28 experience points from this morning's session. I think I'll stop there for now. I think that's probably a good stopping point. Just over, looks like about 40 minutes total. I had a little bit of a snafu at the beginning, trying to get everything. I will fix this camera to be better for next time. But there. So, Math Academy, Foundations 2, 98% complete. Still at 98%, but a few days away from finishing this out. And then I'll start on Foundations 3. I had fun. Hope you had fun as well. Let me know if you have any comments on things I could improve, change from the math aspect or from the streaming aspect. I am new to this, but I'm having fun. I hope you enjoyed this. See you next time.